Check. Good morning, good afternoon, good evening. This is Dr. Garais, BIO116, Anatomy and Physiology II. This is a reproduction of chapter 17. I don't know what happened to my original one, but here we go. This is chapter 17. Maybe make it a little bit smaller. Alrighty, this is the digestive system. Digestive system is part of your metabolism, and it's part of breaking down foods, because ultimately we only want the monosaccharide glucose, and then everything else becomes waste. There are two forms of digestion, mechanical and chemical. Mechanical uses visceral muscle, teeth, to break down large pieces of food into smaller pieces of food. Now, mechanical digestion does not change the chemical composition. So if I start chewing on a piece of on some fat, it's still fat. But chemical digestion, enzymes, we know that what enzymes do to the substrate is change it. So for example, chemical digestion, an enzyme, an example would be a lipase. Lipase will change lipid into fatty acids and triglycerides. And then there are other lipases that break down fatty acids and triglycerides even more so. Okay. Another thing to note here is these four terms: ingestion, propulsion, absorption, and defecation. These are functions of mechanical and chemical digestion. Ingestion, of course, you have to put the food into your mouth. Propulsion, it has to be moved from one place to another, from the mouth to the stomach, to the intestines, and then in the intestines, specifically your small and large intestine, good things have to be absorbed. Water has to be absorbed, and we'll talk more about that regarding the small and large intestine. And last but not least, defecation. You have to create feces, and feces are any waste product, anything that the system doesn't need to make ATP. Okay? That is why the digestive system is called the GI, or gastrointestinal system, or the GI tract, or also known as the alimentary canal. So it's essentially a single pathway. And slide 5 is very nice because it has all the members of your alimentary canal from your mouth to your anus and their functions. And we also have accessory organs, 4 of them: your salivary glands, liver, gallbladder, and pancreas, that food does not pass through them, but they aid in the chemical digestion of food. And here, accessory organs, alimentary canal. Again, starting from the mouth all the way to the anus. There are 4 layers. The innermost layer, so the outermost layer would be here. Inner is here. And we already know the visceral and parietal peritoneum, and in between them is the serous fluid. We already know that. We've seen that in like 3 or 4 chapters. Muscularis is the middle layer. Submucosa is the layer that has all the nourishment, which is arteries, veins, nerves, lacteals. Submucosa. And the mucosa, innermost layer, that has all the goblet cells. The function of mucus, the majority function of mucus in the digestive system is for lubrication, so that food and food products go from one area to another. Another thing you'll notice is there's a lot of surface area. That's why there's a lot of crypts, and like everything is looping around. There's a goblet cell, nice little lacteal in here. There are also 2 types of movement in this alimentary canal: mixing movement and propelling movements. Mixing movements, such as your small intestine and churning in your stomach, right? And propelling movements which is like peristalsis, which is the function of your esophagus that brings food from your oropharynx all the way down to your stomach. Propelling movements go in one direction. Mixing movements, of course, mixing is all different kinds of directions. Both movements are rhythmic. Both movements require visceral slash smooth muscle and are controlled by the autonomic nervous system. You can't make yourself do peristalsis. You can't turn your stomach on command. All that is autonomic nervous system. The mouth, that's where we have ingestion. That's where we have voluntary control. You can control how much do you chew. Mastication is the medical term for chewing, right? Your lips, cheek, tongue, and palate, especially your lips and your tongue, they are sensory organs to make sure that whatever you put in your mouth is not too hot, not too cold, and or potentially poisonous. This is the uvula. It acts as a rudder to direct food into the back of the throat or pharynx. You have your hard palate up here, and then soft palate here. Flanking the hole to go down into your esophagus or food tube are your palatine tonsils. We'll show other view of your tonsils. Remember, your mouth is a very pathogenic place. You could brush your teeth all day, and there still be a significant amount of pathogens. Therefore, your tonsils, right, will protect you there because the tonsils have immune function. They act kind of like much larger lymph nodes. Cheeks, facial expression, nice. Lips, already stated that. Your tongue is not only for the taste, which is sensory, it's also mechanical breakdown. Your tongue is a relatively large muscle. It's going to smash food up into your hard palate and then stroke the food into your soft palate so that your uvula can direct it down into your esophagus. We already know, and when you eat, the first part of your larynx, which is your part of your vocal cords, the first part of that cartilage right here is called your epiglottis. It is going to cover, the epiglottis will cover the trachea while you eat and drink because you don't need any food or water to get into your lungs. That's why you shouldn't talk and eat at the same time. Hard and soft palate. You also have palatine tonsils. You have pharyngeal tonsils, which are also called adenoids, okay, because they look like glands, but they're not. That's what an adenoid is. You could see here, let's zoom in. You could see here, you have several sets of tonsils. You have pharyngeal tonsils, which cover the back part of your pharynx or throat. Palatine tonsils here, right? That's even further down. And then your lingual tonsil, which is associated with your tongue. You could also see the level of your tongue here and how big it is versus what you see here. It can smash food mechanically up here into your hard palate and then moves it back here to the soft palate. You could, there's a swallowing video. X-ray. Here you go. Here's a nice little ditty. See somebody swallowing. You see, they're chewing, that's mastication right here. And then when they swallow, watch what the tongue does. Moves things from the hard palate, smashes it, and then to the soft palate, down. And do you see how fast the food goes down? Because the esophagus here, right, which is your food tube, has peristalsis. It helps it down. And you notice here, look what happens to the trachea. It closes. This is the trachea. You can even see a little bit of the cartilaginous rings. But the epiglottis here, it covers the door so that no food comes down. See? Neat, huh? Oh, well, I think it's neat. Okay? And of course, that food slides down there. Your mouth is dirty. Food is dirty. So you're going to need those 3 sets of tonsils. And they have an immune function. And they act like a very large lymph node. And we know that lymph node has lymph fluid in it and has the full complement of white blood cell differential. Teeth, they're good for mastication, mechanical digestion, biting, grinding, tearing food. Not going to go too much. We're not going to go into food, teeth. Let's go into glands. So mastication is mechanical breakdown of food. But with mastication, you have salivary glands. You have 3 sets. The largest set is your parotid gland, located here in your cheeks. They secrete serous saliva for lubrication and amylase. Amylase is the enzyme that will start breaking down carbohydrates. So things like starch, break down starch into a disaccharide. And we're going to talk about what happens to the disaccharides later when we talk about the stomach and the pancreas. Your submandibular glands located underneath your mandible, jawbone right here. They secrete serous fluid and mucus. And lastly, the sublingual glands underneath the tongue mainly secrete mucus. So know which secretions. This looks like a beautiful matching as well. Other different views, and you could see that the glandular substance here, the glands here, they kind of look the same exact like tonsils. That's why when you call your pharyngeal tonsils, you call them adenoids, because oid means resembling, adeno is nasopharynx, pharynx, laryngopharynx, nice to know. You got to know the swallowing mechanism. The first stage is voluntary, second and third stage is involuntary. The big thing about the second stage is the epiglottis closes off the top of the larynx to protect the trachea. We don't want any food or drink that's dirty, all of it's dirty, to go into your lungs. It's bad news. If that happens, you have the potential for what they call aspirational pneumonia, and it's okay. Peristalsis make a contraction of muscles in your food tube, your esophagus, stomach efficiently. This is just slide 27 of that I just showed you. Your esophagus is your food tube here. It's connected to your stomach. The sphincter in between your esophagus and your stomach is called or lower cardiac sphincter. It prevents regurgitation or GERD. Gastroesophageal. A lot of people have that because we're a nation of salt eaters, drinkers of alcohol, and whatnot. It's your liver, your gallbladder, here's your stomach again, and of course, this is your cardiac LES, or lower esophageal sphincter, and the sphincter that's here in the bottom before the stomach connects into the first part of the small intestine. This is called your pyloric sphincter. Lower esophageal sphincter, also known as the cardiac sphincter, up here, pyloric sphincter here. The stomach, you'll also know folds here. They're called rugae because the stomach can expand and contract because the stomach is actually a 3-layered muscular bladder. There you go. more folds, also known as rugae. Where is the word for, where is it? Sorry, right here. Lesser curvature, greater curvature. Area of the fundus, area, cardiac area right here. And then you have your corpus or body. And then at the very end, your pylorus. Hence the name pyloric sphincter, for the sphincter to prevent food from exiting the stomach. Now, the one thing I forgot to mention, that once you start chewing on food, it ceases to become food, doesn't even look like food. Therefore, we call it a bolus. This bolus moves down the esophagus and then to the stomach, and the stomach does a whole bunch of churning, which is a mechanical mixing, and will do a whole bunch of enzymatic work, which we're going to see in a minute, which is chemical. Here's the area, slide 32, cardiac, fundus, body, and pylorus. Ooh, remember I mentioned in lecture, slide 33, very important. No active versus inactive forms. So anything ogen, inactive, secreted by chief cells. Then pepsin, then pepsinogen turns into pepsin, right? And the function of pepsin is to break down proteins. Gastric lipase, it's going to break down lipids. Hydrochloric acid gets produced by parietal cells because these enzymes need a pH of close to 1. So the pH of the rest of your body should be around, what, 7.4, but the pH inside your stomach is pH 1 or less. Now, why doesn't it just burn a hole through your stomach? Because it can't, because there are a whole bunch of goblet cells making a nice, wonderful, protective covering or layer of mucus to protect against that harsh acidic environment. And if you're stressed out or you drink too much or you have genetic disposition for it, this mucosal lining can wear away and there could be problems. You'll get an ulcer, and that's not good. Parietal cells produce hydrochloric acid. Parietal cells also produce intrinsic factor. Intrinsic factor is required for the absorption of vitamin B12, which is beautiful for your bones. Remember from last term, B12, bones. Again, you could see all those glands inside here. Okay, next. Remember the submucosa had arteries, veins, and nerves, so it has something called the myenteric plexus. The myenteric plexus is connected to your autonomic nervous system. The autonomic nervous system is either sympathetic or parasympathetic signals. Sympathetic signals or impulses decrease gastric activity. Parasympathetic impulses increase gastric activity. There's also hormonal regulation. If you have somatostatin getting released, then it should inhibit hydrochloric acid secretion, right? So somatostatin means soma, body, statin, stand still. So if you want your body not to stand still and not grow, well, that's somatostatin will get released. Gastrin will do the exact opposite, increases gastric juice. And finally, cholecystokinin or CCK. CCK gets released when there's too many proteins and fats detected in the small intestine. That means your stomach is processing things too quickly and it's not finishing or doing its job well. Therefore, we have to slow everything down, decrease gastric motility, which is the exact opposite of gastrin, because the stomach needs more time to break down things. Vomiting center, we already know, medulla oblongata. Here's some churning and mixing illustrations on slide number 37. Now, food, when it's in your mouth and it's being worked on, the saliva and the chewing, mastication, right? It ceases to become food, it becomes a bolus. That bolus goes down your esophagus and then ends up in your stomach. Now, your stomach is going to do a number of things on it. And after it does, right, it's no longer a bolus, it's now called chyme, Chyme. Now, this chyme, when it goes into the duodenum, which is the first part of the small intestine, it's going to have another set of amylases, lipases, and peptidases because there's going to be some leftovers from the stomach, right? And now you recall what amylase does, lipase does, and carboxypeptidase. Add that to your enzyme that eats up or digests proteins. Nucleases are easy; they digest nucleic acids, and bicarbonate. Remember, we mentioned that the stomach's pH is 1 or less than 1. So when the chyme comes out of the stomach into the small intestine, it's rather highly acidic. It comes down to like pH of 4, not 1, because if it was 1, it would burn right through your duodenum. So let's say it's around pH 3.5, pH 4. So bicarbonate gets released so that the 4 can be closer to 7 or to 7.4 to be exact. Okay, so bicarbonate, pancreatic alkaline juice to buffer stomach acid when it comes out into the duodenum. Your duodenum is the first part of your small intestine. Liver, located in your right upper quadrant, largest metabolic organ, and it's got a ton of things. They're in lobes because it's really important, and the lobes can kind of like sequester or keep at bay cancers, infections, things of that matter. Here's your gallbladder located in the inferior surface of your liver, and then you can see it here, typically peeks out of there. And then you have a set of ligaments that hold these 4 lobes together and then attach it to the abdominal wall. Now, the liver functions, I recall what we did in class. Put a whole bunch of them together, like put the first 2 together, because it produces glycogen, storage form of glucose. Because when you eat, that's the first place, it's called first pass effect. When you eat food or the food products, I guess have to be worked on by the liver, because once I grab up my glucose, we're going to store that glucose first in the, and if there's anything excess, we of course fat. Can make or break carbohydrates and left carbohydrates, proteins, and lipids. So it can either break them down or make them. So that's this chunk of the list. Right? It has storage forms for not only glycogen, which is a storage form for glucose. You can have iron in it, vitamins A, and the intrinsic factor. Right? And last but not least, we already know, not last but not least, but what I said, that's wishful thinking. This ties cells, we're at 120 mark. It takes away toxins. We kind of all know that, when people talk about, oh, you're gonna drink another drink, you're gonna ruin your liver, and yes, you are. Acts as a blood vessel reservoir because it's highly vascular, and it also creates bile. Now we're going to talk about bile, and that's what's in the gallbladder. So this is a tricky question. Where do you produce bile? You produce it in the liver. Where do you store and secrete it? You store and secrete it at the level of your gallbladder. Components of bile salts. What is the function of a bile salt? Well, it's created from cholesterol. It is an emulsifier. It is not like a lipase where it'll break down lipid into triglycerides and fatty acids. It just simply emulsifies the fat, meaning it makes the fat more easier to handle. Like instead of having like a golf ball sized not golf ball, like a beach ball sized thing you want to break down versus something the size um, of a golf ball, right? So what do emulsifiers do? They break down fats globules into smaller fat globules called micelles. And the micelles can be taken in or out by cholesterol, which is, remember, a vehicle for fat, and another vehicle for fat is another lipoprotein called, having a moment, called chylomicron. And there's a slide of it further down here. Gallbladder, remember, storage and secretion of bile. Okay, that's gallstones. Again, we're not going over pathology, just the normal anatomy and physiology. So lipase changes lipids chemically, but an emulsifier, also known as a detergent, right? That's why it's kind of like the way soap works, and that's why they call an emulsifier a detergent. It's gonna turn big fat globules into very small ones, and those small ones are called micelles. Absorption of A, D, E, and K, vitamins A, retinol for your vision, vitamin D, calcium absorption or calcium balance, vitamin E for antioxidants to protect your joints in older age and during damage, and vitamin K for hemostasis, also known as clotting. Small intestine, we already said the function is to absorb um, nutrients. Okay, so there's going to be a lot of rugae or folding. And you can see here, there's a whole bunch of folds. And the folds have folds. And the folds that have folds are called plicae circulares, which are indicative of, if you open somebody up and you see plicae circulares, that means you are at the level of the small intestine. The small intestine has three parts: your ileum, your duodenum, jejunum, and ileum. The ileum is the last part, duodenum is the first part. The last part, ileum, let's go through this first. There's peptidases, sucrase, maltase, lactase. This slide 50, nice to know. And they are in the secretions of your small intestine. It's not my eye, I'm yawning. If it's not yawning, I'm coughing. Ugh. I'm having a banner morning. Here's the thing, capillaries we showed about. Remember micelles, mentioned that, and chylomicrons, they're triglyceride clusters. It's actually proteins surrounding a triglyceride. That's what a chylomicron is. And they can be absorbed by lacteals. So can micelles. Okay, here's an example of it. And look, packaging. Remember, smooth endoplasmic reticulum makes fat, makes sugars. Large intestine. The large intestine and the small intestine have a valve that separates the two, or keeps all the things that we want in the small intestine, and keeps all we want, which is most likely feces and water, in your large intestines. And that is your ileocecal valve. Okay. Cecum is the first part. Then you have your colon, which is, you have ascending, transverse, descending, sigmoid colon, and then your rectum, and we're going to talk about anus in a second. So here you go. Here's your cecum. Here's your ileum, which is the last part of your small intestine. There's more of the small intestine, but there's way more surface area in the small intestine. In the large intestine, you can see here, this is your cecum, this is your appendix, and ascending colon, transverse colon, descending colon, goes into your sigmoid colon, and then last 10 centimeters is around, that is your rectum. Rectus means straight, so the last straight tube is around 10 centimeters, give or take. And then the anus, which is comprised of two anal sphincters, an internal and an external. The internal is autonomic nervous system controlled, okay? But your external is skeletal muscle controlled. So that's how you can hold in your feces. But there's regular contractions, and it's called the defecation reflex. Once this part here and here start filling up with feces, it'll automatically open your internal anal sphincter. But that pressure will win eventually, and you will defecate or release all those products. Now, 70% of defecation or feces has water in it. So dehydration is an issue, especially if your patient's going through diarrhea. Okay. You'll also notice here these things here, this line and these little pouches. That's called Taenia coli. Those are specifically for the large intestine. The appendix used to be a part of it, but it's not really anymore. But if the appendix gets infected, like in appendicitis, then what do you call that? This area can be easily infected, especially if there's rupture of this appendix. Here's a nice barium study, lower GI study. We give you something that glows in the dark upon x-rays, so you can see where blockage is, like here. Look at that. Something stuck in there. This is your external and internal anal sphincters, the rectum, the last part. This is your external. Look at your internal. All the way runs up to here, but the external, it's this little bitty part on the bottom. So who's going to eventually win? Right? The production of feces and the evacuation of feces, and that evacuation is called defecation. Taenia coli has an immune function, and the pockets that are the mold for the feces, see how this is a pocket, this is a pocket, this is a pocket. Those pockets are called haustra. Large intestine, of course, has tons of goblet cells to make mucus because we need lubrication to get that feces out. There are also a normal intestinal flora like E. coli. They normally are there, and they're very, very powerful in producing vitamin K and vitamin B and thiamine. Okay. Then you could have some gas. The gas is called flatus, Flatus, mixture of nitrogen, oxygen, methane. Yes, you can light your farts on fire. Please don't try this at home. Movement, defecation, mass movement, of course, peristaltic waves, 2 to 3 times daily. And you also have the defecation reflex that we talked about. Once the feces moves into the rectum and the rectum starts expanding, what will happen? The medulla oblongata set up the reflex that the second that happens, external anal sphincters can only hold the feces so far. There'll be automated relaxation of the internal anal sphincter and all that pressure to get to the bathroom or to defecate. Look at here, water. Majority of your feces or your waste part is water. So if you're having diarrhea, you're going to be throwing out water as fast as you're taking it in, and then there's a potential for dehydration. Pungent is a nice way of saying that it stinks. Hydrogen sulfide is the main culprit. And that's all I got. All right, make sure to try those Cahoots one of your classmates made. Study, study, study at least once a day. Um, Remember, you will cherish the days you're in school, especially if you don't know something. So with that being said, goes thank you, and I will see all of you in class. And if I don't, it's December, 4 days away. Happy birthday to whatever higher power you believe in. Right? See you in class.